What's up, everybody? Mr. Kozad back with you for another video lesson. Today's topic is on solving trig equations. This lesson is intended to be a review of solving trig equations. It is not intended to be maybe the first time you go through this, just kind of a quick refresher on how this process works. So to be successful, grab some paper, grab something to write with, and feel free to take notes with me as we go through this together. If it's going too fast for you, it goes a little bit faster than class. If it's going too fast, please feel free to pause. You can go back and watch something a second time if you want to hear an explanation again. Or if it's going too slow for you and you feel like you're getting it, you can fast forward to the next problem. It's going to be awesome. So hopefully you're ready to go, and let's dive right in. So our very first example, solving trig equations. Okay, example 1 says solve for x for the interval 0 to 2 pi. So let's talk about this for just a minute, okay? This is called a restricted domain, okay? It's called a restricted domain. And what that means is if you remember with angles in trigonometry, we can keep going forever, okay? Angles, you can just keep going, keep rotating. Every complete rotation is 2 pi radians, okay? So we can just keep rotating and rotating and rotating and rotating. Well, in that case, in all of these coterminal angles that we would have, we end up having the same sine values or cosine values or really any of the trig values. So what this does, this just makes it a little bit easier for us. It's saying, okay, we're only going to look at one rotation on the unit circle. We're going to go from 0 to 2 pi. Now, 0 and 2 pi are coterminal, so if you ever have to choose between using 0 or using 2 pi, look very closely at the interval notation, and you're going to use the 0 because it's bracketed, and the 2 pi has a parenthesis. So if we have to choose between 0 and 2 pi, remember, 0 and 2 pi have all the same trig values because they're coterminal angles. Okay, if we have to choose which one we're going to use 0. Okay, that's actually going to come into play in a problem that we'll do together here in a little bit. But let's talk about this one. So this is super, super easy. Sine x equals -1/2. Basically, your objective here is you want to find all the angles where sine is -1/2. So this is definitely an application of the unit circle, okay? So if you don't know the unit circle or haven't heard that before, you might want to stop here and go find some help on unit circle before you continue this. But basically, what we're looking for first is we want to know which quadrants on the unit circle is sine negative. Okay, so we can eliminate quadrant 1 because we know sine is positive in quadrant 1. We also know that sine is positive in quadrant 2, so we can eliminate that. So the next thing that you have to identify is what unit circle angles give you a sine that's 1/2. So if you remember from class, okay, sine of an angle on the unit circle is y/1. So in other words, what angles on the unit circle have a y value that's -1/2, okay? So that's going to be the over 6 angles, and we're going to have 2 of those. We're going to have one of the over 6 angles in quadrant 3, and we're going to have one of the over 6 angles in quadrant 4. So to answer this question, we would say that x equals, now we just need to remember what each of those over 6 angles is in each one of those quadrants. So in quadrant 3, it's 7 pi over 6, and in quadrant 4, it's 11 pi over 6. So there are 2 places between 0 and 2 pi where the sine of x equals -1/2. That's 7 pi over 6 and 11 pi over 6. Okay? All right, let's go on to number 2. So same restriction on x. It says solve for x on the interval 0 to 2 pi. And this time we have a different function. Cosine x equals 1 over square root 2. Now, you might be looking at this, 1 over square root 2, and think, well, that's not any value that I've seen on the unit circle. Well, it actually is, because if we rationalized this fraction, by multiplying by a square root of 2 on the top and the bottom, we end up getting square root of 2 all over 2. And that should definitely be a value that we recognize from our unit circle. So what this problem's asking you to do, it's asking you to find where on the unit circle is the cosine of x equal to root 2 over 2. So I like to think about my unit circle, okay? And I want to eliminate the quadrants where cosine is negative, okay? So cosine is negative in quadrant 2 and quadrant 3. So cosine is positive in quadrant 1 and 4. And remember, as you're thinking about this, that the cosine of an angle on the unit circle is x over 1. So in other words, you're trying to find where is the x coordinate, root 2 over 2. And hopefully you remember that the root 2 over 2 is always associated with the pi over 4 angles, okay? The pi over 4 angles. So there's a pi over 4 angle in quadrant 1 and a pi over 4 angle in quadrant 2. So what we want to do here is we want to list out those angles. So x equals, quadrant 1 is pi over 4. Quadrant 4 is 7 pi over 4. Final answer. The two places on the unit circle where the cosine of x equals root 2 over 2. Now, every time we talk about this, somebody wants to say, okay, well, Cosad, can't you also say that negative pi over 4 is coterminal with 7 pi over 4? So why didn't we list negative pi over 4 as an answer as well? Okay. And again, I would point you back to the restricted domain. Negative pi over 4 is not in the domain for x, so you can't use it. You've got to start at 0 and go counterclockwise and end at 2 pi. Anything on that interval is acceptable. That's why we can't necessarily use negative pi over 4. Even though that's true, the cosine of negative pi over 4 would also be root 2 over 2. Negative pi over 4 is not in the domain that we were given for x. Okay? All right, here's another type of problem that you could see. Sometimes you'll see some trig functions that are split, okay? Generally speaking, your goal is going to be to get these trig functions on the same side of the equal sign. So I'm going to add cosine x to both sides. Now, when I do that, you have to really think about the left-hand side, okay? If you have one cosine x plus another cosine x, you now have a total of 2 cosine x. And then we have just root 3 left over on the right-hand side. So if we divide both sides by 2, we get cosine x equals root 3 over 2. Again, root 3 over 2 should look familiar for us. So think about it in the context of your unit circle. So cosine is positive in quadrants 1 and 4. We just talked about this one. Okay. But now you're looking for where is the cosine equal to root 3 over 2. So that's when the x value is root 3 over 2. And that is the pi over 6 angles. That's going to be the pi over 6 angles. So what's the pi over 6 angle in quadrant 1? It's just pi over 6. And what's the pi over 6 angle in quadrant 4? 11 pi over 6. Again, as you're going through these problems, it's really, really important that you either have a unit circle labeled that you can look at, or you just have a pretty good memory of the unit circle. Okay? So the next type of problem you could see, and I actually had to edit this. I typed it wrong when I made the notes. So if you printed the notes yourself, make a change to this problem. Same interval, same directions, but this time sine squared x equals 1/2. Now, it's really important that you know that sine squared x is the same thing as saying sine x squared. That's just the notation that we use to square trig functions. Okay? So you're going to solve this just like you would an algebra problem. You're going to want to get the sine x all by itself. In other words, we want to get rid of the squared, okay? So to get rid of the second power, we're going to square root both sides. So when I do that, I get sine x equals. Now this is where you have to depend on some good Algebra 2 skills, okay? Because you have to remember when you square root both sides, you have to have a plus or minus in front of your radical. So it's plus or minus the square root of 1/2. Now we can clean up the square root of 1/2. We can say sine x equals plus or minus the square root of 1 is 1, and we have the square root of 2 on the bottom. And we actually just saw this a problem ago. We can rationalize that denominator and say sine x equals plus or minus the square root of 2 over 2. So now we're ready to think about our unit circle, okay? So we're looking here for all the places on the unit circle from 0 to 2 pi where the sign is either positive or negative root 2 over 2. So either positive or negative, it can be either one. So there's actually an angle in each quadrant that's going to achieve this. Remember, when you see root 2 over 2, that's always going to be the over 4 angles. So our solution here is going to be that pi over 4 angles in every single quadrant. So let's write those out. Quadrant 1 would be pi over 4. Quadrant 2 is 3 pi over 4. Quadrant 3 is 5 pi over 4. And quadrant 4 is 7 pi over 4. So there are actually 4 solutions to this problem. Now again, the reason that there are 4 solutions to this problem was because when I took the square root of both sides, I need a plus or minus in front of that radical. So that basically means you can have either positive root 2 over 2 or negative root 2 over 2. So that's why we have an answer in each of the 4 quadrants. Okay? All right, guys, we just have one more I want to show you, okay? There are some trig equations that get a little bit more complicated than what we're doing today, but we're going to just kind of keep it simple for us today. We're not going to get into any trig identities and trig equations. For this class, you don't need to know any trig identities. You would have done that in pre-cal. But for what we need for calculus, you guys will be fine with what we're doing today, okay? So last example together, same directions, different kind of problem, okay? So this, when you see something formatted like this, it's a trinomial, okay? It's a trinomial where the first term is squared, the second term is linear, and the third term is a constant. So if you've been doing math long enough now to know that this is going to be a factoring problem, okay? We're going to factor. And maybe to think about it a little bit better, think about this equation as 2x squared minus x minus 1 equals 0. Okay, if you think about it like that, if I gave you 2x squared minus x minus 1 equals 0, you could probably factor that pretty quickly. Okay, you would factor that to 2x and x are my first 2 terms, and then my last 2 terms would be minus 1 plus 1. I think I'm just double checking that. Yeah, that would be correct. Okay, so if you can factor 2x squared minus x minus 1, you can also factor this trig trinomial. Okay, the only thing that's going to change with my factors is instead of using x, you're going to use cosine x. So that would be 2 cosine x plus 1 times cosine x minus 1 still equals 0. Some of you might need to pause that right there and either listen to that explanation again or just take a second, pause, and in the quietness of your own house or room or wherever you are, think about what just happened, okay? We factored that trinomial just like we factor normal trinomials, but instead of just using x, the variable here is cosine x, okay? And if you don't believe me, FOIL this out. FOIL it out, and I guarantee you, you're going to get this, okay? All right, so now once you have it factored, then you set each factor equal to 0. So 2 cosine x plus 1 equals 0, and then cosine x minus 1 equals 0. So we're going to solve each one of these independently. So the first one is cosine x equals negative 1/2. Okay, so now we're thinking about the unit circle, and we're thinking, where is cosine negative 1/2? Okay, well, cosine's negative 1/2 when we have the over 3 angles. When we have the over 3 angles, because that's x over 1. So we're looking for the over 3 angles, and where cosine is negative, cosine's negative in quadrant 2 and quadrant 3. So I'm essentially looking for the over 3 angles in quadrant 2 and 3. So the over 3 angle in quadrant 2 is 2 pi over 3. The over 3 angle in quadrant 3 is 4 pi over 3. So that's half of my answer. Okay, that's half my answer. Now let's come over here and solve the second half. Cosine x equals 1. Oh man, okay. So this is one of those special cases. When you have trig functions that either equal 0 or 1, you've got to think here, okay? So think about your unit circle, and where does the cosine equal 1, okay? And the cosine equals 1 at 0 and 2 pi. Okay, so this is what I was alluding to at the very beginning with that restricted domain. The restricted domain is going to come into play here. So how do you pick between 0 and 2 pi? Both of them have a cosine that's 1, and both of them are in one rotation. So that's when you depend on the formatting of your interval notation. Since they use the bracket on the 0, we're going to choose 0 instead of 2 pi. Because again, 0 and 2 pi are coterminal, which means all their trig functions have the exact same values. So instead of listing them both, you only pick the 0. Okay? So this actually will put all of this together. We have 3 solutions here. We have 0, we have 2 pi over 3, and we have 4 pi over 3 for my final answer. Okay? So that's it. That's all you need to know for this class in solving trig equations. Again, there are some way more complicated problems that are out there that if you want some help with on some of those, I'd be happy to help you. But this is just kind of a quick intro into some of the basic general concepts of solving trig equations. Hope you enjoyed it, and I will see you next